Okay, get ready, because today we're going deep on lithium niobate.
Lithium niobate.
You might not have heard of it,
Yeah.
but this little crystal,
It's fascinating.
it really is. It's about to become a huge deal.
Yeah, potential revolution across multiple
I
fields.
mean, we're talking high-speed communications.
Quantum computing, AI.
AI, even super precise sensors.
It's really amazing this tiny crystal is at the heart of all of it.
It is.
Yeah.
We have this fresh research review, hot off the press, January 2025,
Yeah,
that breaks down all the latest advancements.
that's right.
One of the things that really jumped out at me
Okay.
was this concept of
Yeah.
ferroelectric domain engineering.
Right.
So imagine being able to program specific regions of this crystal
Yeah.
to behave differently,
It's like giving the material a brain of its own.
almost like creating tiny customized circuits within the material itself.
Exactly.
Yeah.
And the level of control that they're achieving is just mind-boggling.
It's insane.
This paper details techniques for engineering those domains with nanoscale precision.
That's insanely small.
Oh, yeah.
But what's the point of creating these intricate patterns? What does it actually allow them to do with the material?
Well, it unlocks a whole world of possibilities.
Like what?
For example, by precisely controlling these domains, they're building optical devices that can transmit data at speeds we've never seen before.
Okay, give me an example.
Think downloading an entire movie in a matter of seconds.
Wow.
That's the kind of potential we're talking about.
That's incredible.
Yeah.
But how do researchers even see these tiny domain structures? Are we
Yeah.
talking like some kind of superpowered microscope?
You're not far off.
Really?
They're using techniques like scanning probe microscopy,
Okay.
which allows them to visualize these structures at the atomic level.
Oh, wow.
It's like having a superpower that lets you see the building blocks of the future.
So speaking of the future,
Okay.
one of the biggest breakthroughs highlighted in this research is something called
Right.
LNOI,
LNOI.
lithium niobate on an insulator platform.
Exact.
Can you break that down for us?
Uh-huh.
What makes this so groundbreaking?
Think of it like this.
Okay.
By putting a thin layer of lithium niobate on top of an insulator, they're creating a superhighway for light and electrical signals to travel on,
Okay.
but on a much smaller and more efficient scale.
So smaller, faster, more efficient devices.
That's right.
Got it.
Yeah.
This LNOI platform sounds like a game changer.
It is.
What kind of real-world applications are we talking about here?
Well, for starters, LNOI is revolutionizing photonics.
Okay.
We're talking about next-level data transfer and telecommunications.
Okay. So
It's basically the backbone of our digital world getting a massive upgrade.
So that's how we get those lightning-fast movie downloads you were talking about.
Got it.
What else can this do?
Well,
The research mentioned quantum computing.
that's right.
What role does lithium niobate play there?
LNOI is being used to create more powerful and stable quantum computers, which could revolutionize everything from medicine to material science.
Okay, I know quantum computing is a big deal, but can you remind me why?
Yeah.
What makes it so different from the computers that we use every day?
The key is that quantum computers use qubits,
Okay.
which can be both 0 and 1 at the same time,
Right.
thanks to the bizarre laws of quantum mechanics.
Yeah.
This allows them to tackle problems that are simply impossible for traditional computers.
So with lithium niobate,
Uh-huh.
we're talking about building quantum computers
Yes.
that can solve previously impossible problems.
That's right.
What kind of problems are we talking about?
Okay.
Give me an example that I can really wrap my head around.
Imagine being able to design entirely new materials with specific properties.
Okay.
Let's say we need a material that's incredibly strong,
Okay.
but also lightweight for building, say, a spacecraft.
Okay.
A quantum computer could help us discover and design that material at the atomic level.
That's incredible.
Yeah.
And all thanks to this little crystal. But the research also mentioned AI
Huh?
and something called neuromorphic computing.
Neuromorphic computing.
What's that all about?
It's basically the quest to build chips that mimic the way the human brain works.
So are we talking Skynet here?
Uh-huh.
Or something more like a helpful AI assistant that can finally remember where I put my keys?
I think we're a long way off from Skynet.
Okay.
But these neuromorphic chips could be used to process information in entirely new ways.
Like how?
For example, they could analyze complex medical images and help doctors diagnose diseases much earlier and more accurately than is currently possible.
That sounds like a game changer for healthcare.
It really is.
But if lithium niobate can do all of this, what's holding it back?
Well,
Are there any challenges researchers are still trying to overcome?
Precisely controlling those ferroelectric domains,
Right.
especially at such a tiny scale, is still tricky.
Uh-huh.
But researchers are making real progress, particularly with thin-film lithium niobate.
So they're getting better at manipulating this material at the atomic level. They are. What kind of breakthroughs are they making in that area?
One really exciting technique is called domain inversion by laser writing.
Okay.
They use a focused laser beam to essentially flip the polarization of specific regions within the crystal,
Hold on.
creating those custom-designed domains we talked about earlier.
They're using lasers to create patterns on a crystal that's smaller than a human hair.
Yeah.
How is that even possible?
It's incredibly precise.
Wow.
They can create domain patterns that are just a few nanometers wide.
Jeez.
And that level of control is essential for creating the kinds of high-performance devices we've been discussing.
So it's like they're using lasers to sculpt the material at a microscopic level.
Exactly.
But laser writing isn't the only tool in their arsenal, right?
Absolutely.
The research mentioned other techniques as well.
They're also exploring methods like electric field pulling and electron beam writing.
So they've got options.
Each technique has its own strengths and weaknesses. So researchers can choose the best tool for the job, depending on the desired application.
So it's like a high-tech toolbox for manipulating matter at the atomic level.
Pretty much.
This is all incredibly fascinating.
It is.
But before we move on, I'd love to dig a little deeper into some of the specific applications of this technology.
Sounds good to me.
Well, I'm particularly interested in the potential of lithium niobate in photonics.
Okay.
We talked about faster data transfer and telecommunications.
Right.
But what does that actually look like in the real world?
You're asking the right questions.
How will this impact our everyday lives?
Imagine a world where you can download an entire season of your favorite show in the blink of an eye,
No more buffering.
or have video calls that feel as real as being in the same room.
Okay, so how does lithium niobate actually make that possible?
It all comes down to its unique properties.
Like
One of the key factors is lithium niobate's piezoelectric nature.
piezoelectric.
It's a bit of a technical term, but it essentially means that when you apply pressure to the material, it generates an electric charge.
Okay.
And conversely, when you apply an electric charge to it, it changes shape.
So it's like a two-way street between mechanical force and electricity.
Exactly. Interesting. And lithium niobate is incredibly efficient at this conversion.
I see.
This property is what allows them to control the flow of light through the device with incredible precision and speed.
So this piezoelectricity, it's not just for communication.
Yo.
It's actually being used in medical imaging already.
That's right.
How does that work?
Think of ultrasound technology.
Okay.
Lithium niobate crystals are used to generate the sound waves that create images of the inside of the body.
So they're sending out the signal.
Yes. And those same crystals are also used to detect the echoes of those sound waves,
Oh, wow.
which is how the image is formed.
It's amazing how one material can have such a wide range of uses.
I know.
It makes me wonder what other applications they'll discover down the line.
Who knows?
Speaking of which, we touched on quantum computing earlier.
Yes,
It's one of those things that sounds both incredibly complex and incredibly exciting.
it is.
Can you give me a better sense of what kind of problems quantum computers can solve and what role lithium niobate plays?
You're right. Quantum computing can be a brain twister.
It can be.
It's such a different way of thinking about computation.
Right.
One promising area is drug discovery.
Okay.
Right now, developing new drugs is a lengthy and expensive process.
Yeah.
But a quantum computer could simulate the behavior of molecules, allowing scientists to test new drugs virtually much faster and cheaper.
So we could potentially develop life-saving treatments much more quickly.
Exactly.
Wow.
And it goes beyond medicine.
Oh.
Quantum computers could revolutionize material science, finance, even artificial intelligence.
Wow, it really does sound like it could change everything.
The possibilities are vast.
And lithium niobate is essential to making these quantum computers work.
Precisely. One of the key challenges with quantum computing is creating and controlling these things called qubits.
Right.
They're the basic unit of information in a quantum computer,
Okay.
but they're incredibly fragile and easily disrupted.
Right. I remember you mentioning qubits can be both 0 and 1 at the same time.
Yes.
Which is pretty mind-boggling in itself.
It is. How do they even... And to maintain those delicate quantum states,
Yeah.
you need a material that doesn't interfere with them.
Okay.
That's where lithium niobate comes in.
Okay.
It's a very low-loss material.
Oh,
meaning it doesn't absorb or scatter much light.
I see.
Plus, its piezoelectric properties allow us to manipulate those qubits
Okay.
to actually perform the computations.
The lithium niobate is like the perfect stage for these qubits to do their quantum magic.
That's a great analogy.
Right.
And it's leading to some really exciting qubit designs.
Oh, yeah. Like what?
Have you heard of superconducting transmon qubits?
I can't say I have.
These are qubits made from superconducting materials, which means they can conduct electricity with zero resistance.
Okay.
It's crucial for maintaining those delicate quantum states.
So no loss of energy.
Right. And guess what?
Yeah.
Lithium niobate is used as the foundation on which these qubits are built.
So even in this super advanced technology, lithium niobate is a key ingredient.
It really is.
It seems like everywhere we look, this crystal's popping up.
It is.
And another area where it's making waves is in neuromorphic computing, the quest to create artificial brains.
Yes, or at least computers that mimic the way our brains process information.
Okay, back to the artificial brains.
Yeah.
I'm still wrapping my head around that one.
It's a big concept.
What makes lithium niobate so suitable for this kind of computing?
Well, remember how good lithium niobate is at manipulating light?
Yes.
It turns out light is incredibly efficient at transmitting information,
Oh.
much more so than electrons in traditional circuits.
So we're talking light speed computing.
You got it. And with lithium niobate, they can build these tiny, super efficient optical circuits
Okay.
that mimic the way neurons connect and communicate in our brains.
So we're talking like building a brain out of light.
Pretty much.
It's mind-blowing to think about what that could enable.
It is.
But let's bring it back down to earth for a moment.
Okay.
All this talk of quantum computers and artificial brains sounds incredibly futuristic.
Sure.
How does this technology affect me, the average person, today?
That's an important point.
Yeah.
You're already benefiting from the advances in lithium niobate technology.
Really?
Think about the internet.
Okay.
All those faster data speeds and more reliable connections we talked about.
Yeah.
That's thanks in part to lithium niobate-based devices.
So my streaming service not buffering every 5 seconds, I can thank lithium niobate for that.
You can.
Wow.
And it goes beyond entertainment.
Like,
Think about medical devices that can detect diseases earlier, or sensors that can monitor air quality in real time
oh, wow.
and warn you of potential hazards.
So this is like impacting people's lives in a really big way.
Those are all made possible thanks to the incredible properties of this material.
So it's already having a real impact on our lives.
It is.
What's next for lithium niobate? What are the big challenges and opportunities that researchers are focused on now?
There's still so much to explore.
It feels like we've only just scratched the surface of what's possible.
One of the big challenges, as we mentioned before, is controlling those ferroelectric domains with even greater precision.
Right. It's like trying to build a house of cards on an atom.
It really is.
How are they tackling that challenge?
Researchers are developing incredible new techniques.
Okay.
Imagine being able to sculpt the material at the atomic level with a laser, creating incredibly complex three-dimensional structures within the crystal.
Wow, that's
That's the kind of precision they're working towards.
just mind-boggling. What would that level of control allow them to do?
It opens up a whole new world of possibilities for designing even more powerful and versatile devices. Think about quantum computers that are orders of magnitude more powerful than what we can imagine today.
Wow.
Or sensors that can detect the faintest traces of molecules. The possibilities are really endless.
It sounds like we're on the cusp of a technological revolution driven by this tiny crystal.
It does, doesn't it?
But we also talked about some potential downsides.
Right.
Are there any ethical considerations we should be thinking about as this technology advances?
That's a really important point. As with any powerful technology, there's always the potential for misuse.
Right.
For example, as AI systems become more sophisticated and autonomous, we need to make sure that they're developed and used responsibly. We need to be having those conversations as a society now.
Absolutely. It's not just about what we can do, but what we should do.
Exactly.
That sense of responsibility needs to be at the forefront of all of this exciting research.
I agree. Well said. It's like we're holding a tiny crystal with immense power and potential.
Yeah.
We need to make sure we use that power wisely.
This deep dive has been a wild ride. From tiny lasers sculpting crystals to the mind-bending world of quantum computing. I feel like I've been on a journey to the future.
It has been quite a journey.
What's the one big takeaway you hope listeners will remember from our deep dive today?
I think the most important takeaway is that lithium niobate isn't just some obscure scientific curiosity.
Yeah.
It's a material that has the potential to revolutionize countless aspects of our lives. From faster internet speeds to life-saving medical treatments, this tiny crystal is already making a big impact.
It is.
And as research continues, we can expect that impact to grow exponentially in the years to come.
So what does this mean for you, the listener?
That's the big question.
Why should you care about this tiny crystal and its seemingly magical properties?
It's not just about futuristic gadgets.
Right.
It's about the potential to solve some of the world's biggest challenges.
Right.
Exactly.
Yeah.
Whether it's developing new energy sources, creating more sustainable materials, or advancing healthcare, lithium niobate is a key player in shaping a brighter future. It's a reminder that even the smallest things can have a profound impact on the world around us.
Well, on that note, I think it's time to wrap up our lithium niobate deep dive.
Yeah.
I don't know about you,
Yeah.
but I'm feeling incredibly inspired by the ingenuity and the potential of this amazing material.
Me too. It's been a fantastic exploration.
It has.
And I hope you've enjoyed it as much as we have.
And to our listeners, thank you for joining us on this journey into the world of lithium niobate.
Yes, thank you.
We hope you've come away with a sense of wonder and a desire to learn more.
Keep exploring.
Keep exploring.
Keep asking questions.
Yeah.
And who knows, maybe one day you'll be the one making groundbreaking discoveries with this incredible material.
Until next time.
Stay curious.